Hey everyone, welcome to Versatility by Design. My name is Gabor. I'm a developer relations engineer here at Oculus. In this talk, we're gonna look a little bit at the design considerations you need to take to develop games that ship for both Rift and Gear VR. And then we're gonna take a high-level overview of some of the technical details that entails. Quick show of hands, how many people here are like engineers and interested in more of the technical stuff? Okay, how about more the design side? All right, cool, pretty good mixed crowd. I'm excited. So one of the things I do as a development relations engineer is I actually review apps that get submitted to our store, make sure that they meet the technical requirements of the store. And whenever a game comes in that is available for both platforms, those are like hidden gems, and I just love seeing those games. So we're gonna start off this talk by looking at some examples of games that have shipped on both platforms and how they handled the challenge of supporting input for both platforms. That's going to be a little more on the design side of the talk. We're going to switch over to some high-level engineering stuff, look at an introduction to ARM models, what they are, how they work. And then we're going to look at some interesting ways to restrict 6-degree of freedom controllers and how to extend 3-degree of freedom controllers. That's the part I'm most excited about. So before we start, just in case anyone doesn't know, let's kind of define the controllers we're talking about. We have 6-degree of freedom, or 6-DoF controllers, and 3-degree of freedom, or 3-DoF controllers. 6-DoF controllers are the touch controllers. 3-DoF controllers, the Gear VR controller. 6-DoF controllers track both position and orientation. 3-DoF only tracks orientation. 6-DoF tends to come with a pair of 2 controllers. 3-DoF just comes with 1. 6-DoF obviously has more phase buttons and an extra trigger, but we're not really going to focus on the buttons available, just on the degrees of freedom each controller provides. All right, so let's get right into it and look at some games that have shipped on both platforms. First, we have Dead and Buried. For anyone who hasn't played it, it's a zombie horde shooter game. When you're playing with 6-DoF controllers, you obviously got 2 guns, and you aim with full 6-degree of freedom positional tracking. When you're looking at 3-degree of freedom controllers, you only have a single gun, and you aim with an ARM model, which we'll get into later in this talk. And in both versions of the game, you actually flick your wrist to reload. Having this gesture to reload really frees up having to use any buttons. It's a very intuitive way to reload, and just in general, when you can avoid using buttons and substitute them for gestures, you probably should. And one of my favorite parts of the game is that it uses the capacitive thumbstick and capacitive touchpad to move the thumb on the ARM model. This doesn't affect gameplay at all, but it adds a lot of character to the game. And I find myself just sitting in VR, just doing this little thumb motion just for the fun of it. Next up, we have Wands. And for anyone who hasn't played it, it's a magic dueling game. When you're playing with 6-DoF controllers, you can select spells with your thumb pad. You flick left, right, up, or down. And you aim using the full 6-DoF tracking, so you can get some real interesting angles out of it. On 3-DoF, you select spells with the laser pointer, which is going to be a consistent theme throughout this talk. Laser pointer happens to be one of the most intuitive ways to select stuff in 3D. And you aim with the ARM model. Again, we'll get into that. In both versions of the game, you teleport with the laser pointer. You have these teleportation points. You point at them, and it just zooms you right to the teleportation point. This is a really useful way to traverse a level quickly, and several games have implemented this, so most of your players are going to have some kind of intuition to how this works. If you're looking to traverse large areas, this is kind of the way to go. And both versions of the game cast spells using a laser pointer, and I mean that's just because, you know, it kind of works for the game, but also because it's a really efficient motion in 3D. Next up, we have Ultra Wings. You fly an experimental plane. And this game is super fun with the 6-DoF controller. You actually grab the flight stick with your hand and you move it around just like you would an actual flight stick. And then the virtual buttons you actually flip and push with your finger. The 3-DoF obviously has a little bit more limitations. You have to interact with virtual buttons using a laser pointer. And the flight stick orientation maps directly to your 3-DoF controller. So as you're orienting the controller, you don't ever actually lose the flight stick. Both versions of the game map the rudder to buttons, and a large part of this is because there's just no intuitive gesture to control the rudder of a plane. So, when you can use a gesture, try to. But if there's no gesture available, you will have to map stuff to buttons. And flying feels the same, which is actually really impressive. The motion for controlling the flight stick is different on 3DoF and 6DoF controllers. The 6DoF motion is a little bit more interesting, but the 3DoF motion feels just as satisfying. CLOUDLANDS, this is one of my favorite games. It's a mini golf game. On the Rift, you have 6DoF full-on positional tracking. You literally just swing your putter and it hits the ball. Use a thumbstick for quick turns, and you can snap to the location of the ball. With 3DoF controllers, aiming is not so simple. A standard ARM model can't aim accurately enough to play mini golf. So what this game does is it actually breaks up the putting action into 2 stages. The first stage aims the ball with left or right motion, and the next stage swings the ball, which kind of determines the power you hit the ball with. And in the 3DoF version, you use the touchpad to do snap turns. So whenever you have a game where a complex action is possible on the Rift, but it's not really possible on the Gear, you definitely want to try to break that action up before restricting the action. Both versions of the game use an arc teleporter, slightly different than how Wands does it. This method of teleporting is used in a lot of games, and it's good for traversing not so large distances. And again, enough games have implemented this that most of your players are going to have some kind of intuition. And both of these games use a laser pointer in the menu. And the reason you see laser pointers so much is it is intuitive. Don't be shy to use them. Finally, let's take a look at WITCHBLOOD. This is a platforming game in VR, which is interesting. When you use 6DoF controllers, both controllers map and act like a gamepad. And the face buttons of this virtual gamepad perform actions like jumping, ducking, or attacking. A 3DoF controller maps the same amount of actions into a much more restricted controller. So it's actually really worth checking out. The way they made their control scheme is interesting. The Gear VR controller utilizes both the light touch and hard click actions. Now, both versions of the game have very consistent controls because neither version of the game uses any degrees of freedom at all. The controls are consistent in the game and in the menu. It would be really awkward if the game used no degrees of freedom and all of a sudden in the menu you were expected to use a laser pointer. And because there's no position or orientation, everything will always map to the same face buttons. The same action that moves down in the game also moves up in the game. So we have a couple of takeaways here. Use gestures when available. The less buttons players have to memorize, the more natural your game's going to feel. Laser pointers are probably the most efficient way to select UI elements and interact with the 3D world in general. Don't be shy about using them. Orientation is universal, and it can be tempting to just use the orientation of a 6DoF controller, but you can achieve the same feeling with a more interesting action in most cases. Use teleportation. It's easy, it's universal, and it's going to feel the same on both platforms. And be consistent with your design. If you are using a certain amount of degrees of freedom in your game, use the same in your menu. It's really jarring when one uses less or more than the other. So next, let's take a look at some kind of more technical things and discuss how ARM models work. ARM models are mostly used for 3DoF controllers. The controller only reports its orientation to your application. But when you look at how a controller works in, say, Oculus Home or any other application, there's definitely a position involved. So let's explore how we actually get to that position. An ARM model consists of 2 endpoints and a segment between them. One of the endpoints can orient freely. The other endpoint can link to a new segment. Orienting any segment will affect segments below it. So for example, if I was to move my elbow, it would move my wrist, but it wouldn't move my shoulder. The position of the final segment is affected by all the linked segments before it, both their orientation and their length. An ARM model can be driven by forward kinematics, inverse kinematics, or any kind of other input, which we'll get to later. In forward kinematics, you generally tend to have 2 states of the arm, one that's relaxed and one that's bent based on some kind of controller configuration, and you interpolate between the 2. With inverse kinematics, you tend to pick a point in 3D space based on the orientation of your controller, and the position of joints is figured out in a way that it reaches for the point. And when you introduce some more arbitrary controls into the arm model, that's when things can get really experimental and interesting. And we'll get to that in just a little bit. So before we do, though, let's take a look at how to restrict 6-degree of freedom controllers to 3 degrees of freedom. This is actually pretty simple. You ignore the position of the controller. You feed the orientation of the controller into an arm model. And the result of that arm model is your new orientation. The arm model we use at Oculus is actually, the source code is available at developer.oculus.com. It's part of our native mobile SDK. And on our blog, developer.oculus.com/blog, there's a Unity port. Now, the kind of natural thing you would think to use this for would be to restrict a touch controller to mimic a Rift controller so you can speed up your development. But you can use the same arm model on a gear too. And you can use it as the starting point of your own arm model, which brings us to extending 3DoF controls. When you have a 3DoF controller, you can easily add some additional joints. So for instance, where you only have an elbow joint, where you only have a wrist joint, you might get a motion that points left or right. But if you had a clavicle in the neck and then hook your HMD up to the neck, you can all of a sudden dab in VR, which is pretty fun. I'm glad you guys laughed. I really ruined that joke in my practice. You can also add additional joints, such as joints for the other arm, which could be controlled by inverse or forward kinematics hooked up to some kind of a game system, which actually makes the game a lot more interesting. You can also edit the existing arm model, and this is where the previous slide from the 6DoF controllers comes in. So this is the default arm model that we provide, and that's actually me swinging a controller. As you can see, it's pretty good for pointing at stuff, but it's not good for other actions. It's not really good for throwing, where your shoulder moves a lot, and it's not really good for swinging a sword. So what do you need to swing a sword? You need to relax your elbow a little bit, and you need to exaggerate your shoulder. So in the arm model you see in blue, the shoulder's orientation is multiplied by 2, and the elbow's orientation is relaxed all the way. And for comparison, this is the same action. The arm model just has a much wider range of motion. So it's actually a little bit of an engineering effort, but you can design and develop arm models that are better suited to the mechanics of your game. Now, this is the thing I'm most excited about that I don't think has been explored enough, and that's hybrid arm models. You can drive your shoulder joint using the forward kinematics we use for our arm model, but you could drive your elbow joint through some form of direct input. In this example, you can see that little red dot on the touch controller. That's the position of your thumb. As you move your thumb forward, the elbow relaxes. As you move it backward, it contracts. This allows for motions that reach outwards. It takes a little bit of getting used to, but after about 10 minutes with this, I can actually reach out in a Gear VR, pick something up, and pull it towards me, which isn't really possible with the default model. So you can actually design systems like this. This was inspired by how prosthetics work. I was looking into some mechanical prosthetics, and I saw how they were extending motion using secondary actions, and it really inspired me to build this specific demo. And I'm hoping that other people kind of get inspired and try to extend the motion through secondary actions as well. So this was a really quick lightning talk. Let's go through the summary of everything we just covered in less than 15 minutes. If you're designing games that are going to ship on both platforms, make sure your controls feel consistent. Consistency is key to a good experience. 3DoF controllers are driven by ARM models. You can build custom ARM models. If your game involves throwing a ball, you're going to need a lot of motion in your shoulder. 6DoF controllers can be treated like 3DoF controllers by restricting them, and that can be a good starting point to building your own ARM models. And if you're designing a mobile experience, play around with the ARM model, extend that to 3 degrees of freedom, and try to get something that feels really natural. That's it for my talk. I'll be taking questions, comments, rude remarks, whatever you want.